Here we go. Trigonometric ratios. Let's start off with. All right, 24 problems. Find the value of each trig ratio. So, tangent, the tangent function is defined as the length of the opposite side divided by the length of the adjacent side in a unit right angled triangle. Opposite and adjacent, what do you mean? Well, you pick out one of these smaller angles, and it's the length of the opposite side divided by the length of the adjacent side to that angle. All right, so in this case, the angle in question is angle Z down here. So the opposite side is 21, the adjacent side is 28. So the tangent of Z is 21 over 28, which reduces to 3/4. Cosine is the length of the adjacent divided by the length of the hypotenuse. So in this case, it would be 16 over 34, which reduces to 8 over 17. I don't know if they want us to do decimalization. No, they don't, thank goodness. All right, so the sine function is defined as the length of the opposite side divided by the length of the hypotenuse. So that sort of completes the set of primary trigonometric functions. So in this case, it'd be 28 over 35, which reduces to 4 over 5. Tangent, 32 over 24, that reduces to 4 over 3. Cosine of A, that'll be 30 over 34, which reduces to 15 over 17. Sine of A would be opposite over hypotenuse, 32 over 40, which reduces to 4 over 5. Sine of Z, or Z, is opposite over hypotenuse, so 24 over 40, which reduces to 3 over 5. Sine of C would be 14 over 50, which reduces to 7 over 25. Cosine of Z or Z would be adjacent divided by hypotenuse, so 24 over 30, which reduces to 4 over 5. Tangent of C would be opposite over adjacent, which is 27 over 36, which reduces to 3 over 4. Now find the value of each trigonometric ratio to the nearest 10,000th. So in other words, guess so. So I would typically say here, cosine of Z or Z is 12 over 15, which reduces to 4 over 5. And what am I supposed to turn that into 0.8000 like that? We'll see. Just glancing here. Apparently so, to the nearest 10,000th. And that goes on for a few questions, so we better get started. Cosine of C here is adjacent over hypotenuse, so 27 over 45, which reduces to 3 over 5, which decimalizes to 0.6000 to the nearest 10,000th. Tangent of C is opposite over adjacent, so 40 over 30, which reduces to 4 over 3, which decimalizes to 1.333. Tangent of A is 21 over 20, which actually can't be reduced, but you can decimalize it. First divide it by 2, so you get 10.5, then divide it by 10, so you get 0.105, and stick on the extra 0. Tangent of C, opposite over adjacent, so 12 over 35, which 12 over 35, that doesn't reduce. Divide 12 by 5 to get 2.4, then divide that by 7. 24 over 7 is 3 remainder 3, so 3.42857. So I guess it'd be nine, something like that, to the nearest 10,000th. The tangent of x, opposite over adjacent, so 30 over 4, so 3/4, so 0.7500 to the nearest 10,000th. Sine of z or z is opposite over hypotenuse, so 12 over 37. Don't know how to decimalize that. Pretty close to a third though. 0.3243. Sine of z or z is opposite over hypotenuse, so 30 over 50, so 3 over 5, which decimalizes to 0.6000. Sine of 48, this one you have to just simply enter. So you get 0.7431. Sine of 38, 0.6157. Cos 61, 0.4848. Cos 51, 0.6293. Can the sine of an angle ever equal 2? Why or why not? No, as it is the length of the opposite side it is the length of, let's be clear here, it is the length of a leg in a unit right triangle having a hypotenuse, longest side of 1. Sine of x equals a third. Find cosine of x. So that you can do by doing 1. Take a third. 1 squared, take a third squared. So that's 1, take a ninth, which is 8 ninths. And then square root of 8 ninths, which is root 8 over root 9, which is 2 root 2 over 3. And check for everything. Check for everything. Literally, check everything. Never leave anything unchecked. So 3/4, 8/17, 4/5, 4/3, 15/17, 4/5, 3/5, 7 over 25, 4 over 5, 3 over 4. That's all correct. That's correct. That's correct. Okay, that's good. That's good. That's good. And good. And good. All correct. Inverse trig ratios. Here we go. How many questions? 26. Off you go. Find each angle measure to the nearest degree. So we have to use the arc functions or the inverse functions. So it'd be arc sine 0.4848, which is to the nearest degree about 29 degrees. .50, about 31 degrees. Oops. 42 degrees. 52 degrees. I'm going to do these cosine ones. 5878, excuse me. 4226. And arctan 19.0811. 5317. There you go. Find the measure of the indicated angle to the nearest degree. We have opposite and adjacent, so it'll be arctangent of 27 divided by 38, which to the nearest degree is about 35 degrees. Arctangent as well, opposite over adjacent, so 9 over 21, or a seventh, so 23 degrees. 14 over 29, 26 degrees to the nearest degree. Here we have opposite and hypotenuse, so that would be sine. So arcsine of 40 divided by 42, about 72 degrees. Opposite and hypotenuse as well, 10 divided by 39. 24 degrees. And opposite and hypotenuse as well, in fact. And that's actually a half. So arcsine of a half is 30 degrees. And, it's the 1 root 3, 2 special triangle, 30, 60, 90. Okay, it's 13. Let's see, we've got the adjacent and the hypotenuse, so that'd be cosine, arc cosine. So 50 degrees-ish. Adjacent and hypotenuse. About 41 degrees. Adjacent hypotenuse, again, cosine. Oops. There. Here, you can use whatever you want. So I'm going to use the tangent function. But this, I'm going to use the tangent function. So 14 over 48. About 16 degrees-ish. Tangent function. Whoops. 53. Just a few more here. 74. 28. 37. 23, and that's fine. Find an angle x where sine of x is equal to cosine of x. Clearly, that's 45 degrees. Draw and label all three sides of a right triangle that has a 40-degree angle and a hypotenuse of 10 centimeters. Very well. Something a little bit like that. Not scale. I'll pick what appears visually to be the smaller angle, 40 degrees, 50 degrees. There, hypotenuse, 10 centimeters. And 10 cosine 40, about 7.66. 10 sine 40. And that'll do. And now check everything. Check everything. Right. Right, total agreement. Uh-oh. Whoops. Just one doozy. Oh, yeah. Okay. Fine. Yeah. All good. Next up, solving right triangles. Let's get this moving, please. Okay. How many to contend with here? 17. Did you know that 17 was felt to be one of the most random numbers when people were surveyed to choose a number between 1 and 20, which is the most random? And it has many other interesting properties, especially its period. When you divide 1 by 17, you get 0.0588235294117647, which is beautiful. Now, let's see. Find the missing side, round to the nearest tenth. So, here, who's involved? Hypotenuse, adjacent, and the angle, typically theta. So, run through SOHCAHTOA, and we find that it's CAH, C-A-H. We write out cosine of theta is adjacent over hypotenuse. We make the substitutions we need to. Cosine of 72 degrees is 6 over the hypotenuse, which is the one that we actually want, which would be x, rather. And then we rearrange. So x would be 6 over cosine of 72 degrees. And then we get that to the nearest tenth. Which is 19.4. Then, quick check. Does it feel right? Does it sound right? Does it look right? Yes. Okay. Here, basically the same problem. So, but not quite. So what it's saying here is that cosine of 73 degrees is x over 6. And so to find x, just do cosine of 73 times 6, which is about 1.75. But to the nearest tenth, as asked, is 1.8. And I do not feel comfortable putting an equal sign there, because it's not true that it's equal to that. It's approximately equal to that. Anyhow, here, who's involved? Opposite, adjacent, and the angle. That would be TOA, tan. Tan of 24 is x over 12. So 12 times tan of 24. So 5.3-ish. Again, TOA, tan of 37 is x over 12. 12 tan 37 gives you x. So 9. TOA again, tan of 49 is 14 over x. So 14 over tan 49 will give you x. Which is about 12.2. Who's involved? Opposite and hypotenuse. So it's sine of theta. So sine of 51 is 14 over x. So x is 14 over sine 51. which is about 18. Here, opposite and hypotenuse again. Sine of 63 is 16 over x. So x is 16, beg your pardon, 16 over sine 63, about 17.9, so about 18 to the nearest tenth. Check that these sound right and look right. They seem fine. Okay. Opposite and hypotenuse. So sine of 15 is 16 over x. So x is 16 over sine 15 degrees. 16 over sine 15, which is special, but they don't want it that way. They want it there. Just a few more now. So who's involved? Adjacent and opposite. So TOA. So tan of 55 is 29 over x. I think. Yes. Tan of 55 is 29 over x. So x is 29 over tan of 55. Which is about 20.3. Tan of 68 is x over 21. So x is 21 tan 68. About 52. Sounds about right. Looks about right. Based on the 30, 60, 90 right triangle. Who's involved? So hypotenuse, opposite. So sine of 19 degrees. Now let's see. X over that. So it would be 29. About 89 degrees. No, sorry, about 89 linear units, or whatever you want to call it. Wait, have I been going to the nearest tenth? Or what? I have? Okay, that should be 89.1. Opposite hypotenuse. Sine of 21 is x over 22, so x is 22 sine 21, which is about 7.9-ish. Opposite hypotenuse, so sine of 33 degrees is x over 29, so 29 times that. About 15.8. Special triangle, 35 times root 2. And here, adjacent, hypotenuse, so cosine of 47 degrees is 28 over x. So to get x by itself, do 28 over cosine 47. And that gives you about 41.1 to the nearest tenth. Here, adjacent, hypotenuse, so let's see. Okay, so cosine 59 degrees is 34 over x, so 34 over cosine. $66. All right. The solution is to recognize that this is the 45, 45, 90 triangle, and therefore the hypotenuse is root 2 times bigger than the legs. And so do 1 over root 2 and then simplify. In other words, rationalize the denominator so we get root 2 over 2. All right, and now to check. Always check everything. Okay, let me see. Right, correct. That should be 61.8, but I don't know why I rounded that degree. That's fine. That's no. That's not right at all. What? Why did I do that? All right. Put a star and come back. 7.9, 15.8. That's correct. That's all good. And answers vary. And now to fix this. Okay. Who's involved? Opposites. Hypotenuse. So sine of 19 degrees is x over 29. So to get x, just do like that. I think I divided it, which is wrong. And then it'd be 29 times sine of 19, which is about 9.4. And check. And that's correct. And that's good. That's all good. Okay, I'm done. Be well.